Alrighty, hello. It's Saturday and I am making a video. Very excited. All right, so we are going to be doing Module 23, Sensation and Perception, Visual Organization, Interpretation. Here's a lot of different stuff we're going to be covering. Let's get right to it. So the first question is, how did the Gestalt psychologists understand perceptual organization? So they are early psychologists that really just started to look at more specifically how we try to form a whole from separate experiences, separate stimuli, or seeing separate stimuli. And he believed they actually used the German word Gestalt, which means form or whole. And they, based on their research, they kind of came to this conclusion that in perception, the whole may exceed the sum of its parts. So let me explain what that means. When you're thinking of just when you are looking at a bunch of flowers in a vase, and you're going to most often initially, you're not going to really focus on the individual flowers. You're going to just see it as a bouquet of flowers and form a whole in your understanding. And our brain does more than register information about the world. We actually construct perceptions, and we're going to look at some examples of that. We have something called a Necker cube demonstration. And here, when you're looking at this image, you don't really see it as blue circles with three converging white lines. You actually see it as a three-dimensional cube, and we construct that perception. And the only visual stimuli you're actually seeing is the blue wedges, but the circles, lines, and the cubes are all products of our mind, creating that perception, the three-dimensional perception. Here's another term, really important. It's called figure ground perception. And it is really talking, it's almost like selective attention, but focusing on our visual field. That this is called a reverse figure, this example here, because when you're focusing on the vase becomes the figure, and the profiles become the surroundings or the background. But it can reverse, it can change. So then the profiles now become the figure and the vase becomes the background. And it's just helping us be able to form that whole, that overall understanding of our world. All right, so Brianna and Charles are in a dancing competition. It's easy for spectators to see them against the dance floor because of figure ground relationships, because you're able to see them as the figures and then the dance floor is the surrounding of the background. Gestalt psychologists did further research with trying to understand how we group things to form this whole in our understanding. So the Gestalt law, here's some of the actual laws that they found, or rules, is that, for example, proximity, the law, what is proximity? We see here, rather than 6 individual lines, we see 3 sets of 2 lines because of their proximity to each other. We group them together. Here we see, rather than seeing semicircles here, 1, 2, 3, 4, we see this as one continuous wavy line and one continuous straight line. We want to group that together. It certainly, just for us, seems more organized to see it as continuous. There is another Gestalt grouping rule. We call it closure. We fill in gaps to create a complete whole picture when there's things that are missing. So here in these circles, we have, part of the circle is missing. And now it's like created this illusion of a rectangle. But it's really just because we are trying to fill in the missing gaps here. And if you add nothing more than a little line segment to those to close off the circles, you will not see the triangle anymore. So if you just cover that up a little bit, you won't see it anymore. So, all right. This is called the Impossible Doghouse. So it's just one of these things where, we kind of see this doghouse that looks a lot more constructed than it really is. And it's just because of our, the rules of grouping of closure and continuity more specifically here. That you perceive the boards as continuous, even though they're not. We have a very famous experiment. It's called the visual cliff. And this is just to kind of demonstrate that we are born. It's our ability to perceive depth, which is what we're going to be talking about in more detail, and judging the distance between how far away or something is to us, and seeing things, even though our retina might see something two-dimensional, that we know that the objects are three-dimensional. So here's the visual cliff. They took 6 to 14-month-olds, infants. They were placed on a cliff, and the moms asked them to come closer, come here. But because of they had developed and are born with a sense of depth, they did not want to cross because they thought that it was going to drop off, that it was a cliff. So we have different cues to perceive depth. One's called binocular cues, where you need both eyes to be able to perceive and judge depth. We're going to go into and talk about those. One's called retinal disparity. So retinal disparity means that each retina is you're going to basically take the information from both of the retinas to kind of form a whole and understanding of what a picture is in general. And, this happens automatically. But here we're actually creating an optical illusion where you're going to have you just put your fingers together. And when you look, put your fingers together, and you're going to see it looks like like we call it the sausage finger. It's like this floating finger in the middle. And it's because your retinas are not used to seeing information in that way. And the brain is computing the distance, and the greater that the actual disparity is, the closer the object is. So in this case, because it's relatively close and it's trying to make sense of it, it creates this illusion. Convergence is really just about your eyes. The more that they're converging together, that the closer an object is. So if you just think of holding your finger, moving it closer to you, your eyes start to converge. We know it's moving closer. All right, this one, I think there's actually a mistake on this question. So we're going to move past this one. All right, so most of the cues we use are called monocular cues. And I am actually just going to really quickly go through them right now, but we're going to be covering them in detail. And that's really what your activity is in class next week. Okay, so the first monocular cue. So when we say monocular, you only need one eye to perceive depths in this way. The more that something moves up our visual field, the higher it is in our visual field, we perceive it as farther away. Relative size, if you have two objects that are relatively the same size, the one that looks smaller is farther away. So in this particular instance, it's making a joke, but these relatively the same size people, but this police officer back here looks much farther away and looks smaller. So we perceive him as being farther away. Interposition is when one object is blocking another, the object that's blocking the other is closer. And we're going to do lots of examples of this in class. Relative motion we will not do in class, so I'll spend a second with this one. If you are on a train and you're trying to perceive, and you're just taking in the scenery, looking out the window. If you look at, you have we call it the fixation point. If you're looking at the house, okay, things that are closer to you than the house are going to look like they're going in the opposite direction of you. It almost makes you like, a little scared for a second, because sometimes it feels like something's going in the opposite direction. And then things that are past the fixation point look like they're going in the same direction as you, but like at a slower, it's slower. All right, linear perspective is when you are looking, and this is talking about parallel lines converging. Don't mix it up with convergence, which is a binocular cue. This is talking about parallel lines, as you see here in the picture. The more that the parallel lines start to come together and converge, we perceive that as farther away. So here you see he's driving down the road, and as the lines start to converge, you assume he is much farther away. Light and shadow, that depth also can be perceived when relative with the light. We consider, when the light is casting, we consider that closer, and then the shadow is farther away. Creates depth. You've done that in your drawings, and we'll do that in class. All right, so there is also this concept, it's called the Phi phenomenon. This one's pretty cool. We also call it stroboscopic movement. And it just means that when two adjacent stationary lights blink on and off in quick succession, so flashing on and off really quickly, that it gives you a perception of movement. And, we think of blinking marquees when you're driving down the road and you see the message is, going across the marquee, and that is just because they have the lights flickering on and on quickly. And I think of a storybook sometime that have you ever made those little storybooks where you're like, each page was like, the next step of somebody like walking or something, walking down the street or doing something. And then when you flip through the book really quickly, it's actually going to create that on and off quick succession of the lights. And so it makes it look like when you flip through the picture book, it makes it look like they're actually moving and walking. So we're going to talk about perceptual constancies next, which is a top-down process that recognizes objects without being deceived by their color, brightness, and shape and size. So our retinas are going to see sometimes, or the retina, the information they're receiving is going to be different than what you are going to ultimately perceive. Here's an example. It's called color constancy. So here you've got these yellow stickers or dots on this cube, and the illumination is different in different, like where it's being illuminated. So like here, it's definitely not getting as much illumination, and the wavelength, is different than what you're seeing up here. But in all these instances, we assume that the color has not changed, that it is yellow in our mind. And brightness, same thing. Sometimes something here, I think about my shirt. In different environments might seem brighter, but we know that it's still the same brightness of my shirt. And so here it says the perception of constancy depends on relative luminance, the amount of light the object reflects to its surroundings. Even though the banana seemed to change color as the lighting in the room changed, James knew that the color of the banana was not actually changing. That's key word, color. This is due to color constancy. Shape constancy is another one that sometimes our retina will see. It looks as though here, the door is changing shape, but it is actually staying the same shape. Size constancy, same thing. If you are looking at your friend and they're walking down that football field and they look like they're getting smaller, you know that their size still remains constant. All right, here's a little psych funny. Sometimes I wonder, why is that Frisbee getting bigger? And then it hits me. The Ames room is like an illusion that is just taking, like when it comes to our understanding and how we use depth perception cues and hold things constant, that they can actually create this illusion here where the girls are actually the same size, but if you look back here, she looks much taller. And they also here almost look like they're in the same part of the room, or meaning that they're not really one person's not any closer than the other. But in reality, she is actually much closer. even though they're the same size. She's farther away, and then the roof is very different. So it's about the right angles. All right, so. All right, so, one of the other things that we just started noticing is that there are certain parts of our perception that are innate, we're born with. So when they notice people, here are some adults that were blind. They had later they got sight having cataract surgery, and there were certain things that they were able to distinguish figure and ground. They could differentiate colors, but their visual acuity was not necessarily improved, and actually it was very difficult for people. So they do recognize that there probably is a critical period where you need to have exposure to certain stimuli and experiences for you to really be able to like truly see and perceive things that you see in your visual world. So it's not as easy as you think, I guess, is the bottom line. What I'm saying is that having the surgery that could allow somebody the capacity that's been blind to actually be able to see, it's much more complicated than that. Excuse me. All right. They also, I think, did some similar experiments with kittens. They could distinguish color and brightness, but but not the form of a circle from that of a square. So they're lacking, their brain's cortical cells had not developed normal connections. So I guess it's like almost like atrophy. So one other thing, I think it's like the last thing we're going to talk about, is something it's called perceptual adaptation. And that just means that we also have this incredible ability that we can adjust to sensory input, including an artificially displaced or even inverted visual field. So they've done these experiments. Let me just move to the next slide. Where they wear these goggles and they actually invert their world, and they want to just see, can they get used to it? And believe it or not, they can. So over time, you can imagine if you put goggles on, you feel really nauseous. Your world is inverted. So meaning like everything is upside down to you now with these goggles on. So of course, very nauseous at first, not really able to do simple tasks, like eating and, walking around. But over time, they adapted. And so that their perceptual understanding of their world had now adapted to this inverted world. It's pretty remarkable, isn't it? All right, that's it. All right, have a great Thanksgiving, and we look forward to seeing you when we get back. All right, so let me stop this video. Take care.